So this is the last recording for Unit 1. It's a pretty straightforward one, and it's not too long. So we're looking at the structure and properties of solids today. And your learning goal, you should be able to describe the properties of different types of solids, and there are 4 in particular that you're going to need to learn about. So here are the 4 types of solids, or crystal types. We have a network solid, which is comprised of covalently bonded atoms. We have an ionic crystal, which consists of electrostatic attraction of ions. A metallic crystal, which basically is how metals bond together and stay together as a solid. And the 4th is a molecular crystal, which uses the electrostatic attraction of dipoles in molecules. And we all know what a dipole is with those partially positive and partially negative charges. So let's go through each one of those in a little bit more detail. So network solids, covalent crystals. These are some compounds that do not have molecules. Instead, they have long chains of covalent bonds. So for example, in diamonds. So if I move this picture away, you can see that's sort of the structure of what a diamond looks like. There's no distinct molecule in there. It's just a bunch of carbon atoms that are all bonded together. This happens in a 3-dimensional shape, creating a crystal. And what happens is the interlocking structure of these covalent bonds actually makes it even stronger than ionic solids. So you end up with the strongest of the 4 solids. Next one is an ionic crystal. You guys have looked at these definitely last year in grade 11, and we've taken a quick look at them already this year. It consists of the 3-dimensional arrangement in ions. Properties, these ionic crystals are hard, they're brittle, so they're sort of easy to mash up and break apart. They conduct electricity in a liquid state, and they form conducting solutions when they're dissolved in water. They also have a very high melting point. MP is melting point. So here it says the indicated ionic bonds are strong, directional, and composed of ions. So I'm going to show you what I mean by that. So here is a big molecule of sodium chloride. Okay, so you can see that what happens is the sodium ions are sort of the small blue ones, and the chlorine ions are the green ones. What actually ends up happening in an ionic compound is it's not just 1 sodium and 1 chlorine bonded together. They're actually just bonded together, like hundreds and thousands of them, in a 1-to-1 ratio. That's what actually makes the solid. Next one, metallic crystals. So metals in general. Metals normally occur as solids. We know that already. So to keep them solids, especially at room temperature, there must be strong bonds between the atoms of metals, causing them to bond. But if you actually take a look at a metal, say like copper, well, copper, just on its own, doesn't necessarily it's hard to sort of envision. There's no dipole-dipole force. If you have a bunch of positive copper ions, and they're not going to bond together because the positive charges repel. So how do these metals actually stay together, and stay together very well? Here's what happens. Bonding in metals and alloys is very different from in other compounds. And basically you end up with a positive nuclei. So that's all these little dots here, all these little circles. Those are your sort of positive nuclei existing in a sea of electrons. Okay, so there's electrons sort of floating all around these positive nuclei, okay? Because these sea of electrons can move around, this explains why metals can conduct electricity, okay? That is as much detail as we're going to go into for this topic, okay? If you decide to take chemistry later on in university, you'll probably go into a lot more detail, but all you need to know is that for metals and alloys, it basically is a positive nuclei existing in a sea of electrons, and those electrons can move around so that these metals can conduct electricity. All right, so our last crystal is a molecular crystal. The properties of these, they have relatively low melting and boiling points compared to the other 3. They're not very hard, and they're non-conductors of electricity. Okay, so again, we have covalent compounds, we have sharing of electrons, okay, no ions being formed, so we're not going to be able to conduct electricity. Those electrons aren't being moved around, they're just being shared between atoms. But what you end up with is some atoms that end up with dipole-dipole forces or hydrogen bonds, and they can hold themselves together in a solid. The 3D arrangement of these neutral molecules are held together by relatively weak intermolecular forces. Now, we talked about the intermolecular forces being your London dispersion forces, your dipole-dipole forces, and your hydrogen bonds. I call these relatively weak intermolecular forces, even though we know dipole-dipole forces and IMFs are strong. The reason why I call them relatively weak is they're relatively weak compared to the other 3 crystals that I've shown you today. Okay, so here's an example. This molecule here is actually dry ice. So you can see the carbons are there in sort of gray. That's your carbon, and then the red ones are oxygen. So you've got CO2. So that's basically your dry ice. It's frozen carbon dioxide, which is kind of cool. All right. So a couple last slide, properties of these crystals. Boiling and melting occur when the forces between the molecules are overcome with energy from the heat, and a change of state occurs, and we go from either a solid to a liquid, that's melting point, or a liquid to a gas, that's your boiling point. The higher the force of attraction between the molecules, so the higher your intermolecular forces, the higher the melting or boiling point. Only metallic crystals conduct electricity in the solid state. Okay, and they can also conduct when they're molten or in liquid state. Ionic crystals will conduct electricity in the molten state or when dissolved, because ions, again, are free to move from positive to negative poles. So that is all for Unit 1. Hope you enjoyed listening to these, and we will see you in class.